what is the first step here? What do we have to do first? You could say the domain. However, we know the domain of a quadratic function is all real numbers. So we normally start with the
range.
In this particular case, you're right. I would have started even with the range, only if the square was completed. We're completed there. I can't. I don't know what 4x squared plus 8x minus 1 does. My hands are tight on this one. But if I have, it's a very good point. But if I have something like 2, let's say x minus 1 squared and plus 4, then I know for sure.
Okay.
Because x squared, x minus 1 squared, 2 times x minus 1 squared, right? Plus 4. So the range is 4 to infinity. But for this one, I can't. In this format, I won't be able to, till I graph the function, I won't be able to present the range. It's a very good point. Thank you. No, so the first step is the shape. Why is the first step the shape? It's because we know that this quadratic function can open upwards or downwards, meaning it has a minimum or a maximum. How will I determine that even before I graph it? How will I know whether the function is has a minimum or a maximum? Right, exactly. If the leading coefficient. Yes, correct. Since the leading coefficient is positive because it's 4, it has a, that's it. Awesome. Number 2, I have to find the vertex. Here, can anyone give us the vertex for this side problem?
1,
Comma.
4.
Right, because it's x squared, x minus 1 squared, 2 times x minus 1 squared, up 4. So I'm exactly at 1, up 4. So this must be 1 comma 4. But here I can't do that. So what is the recipe for this situation to find the vertex?
Negative b.
Awesome. Yes, yes. Negative b over 2a. So this is the x coordinate, negative b over 2a minus b.
8.
Perfect. 2 times a.
8.
Good. Answer.
Negative b.
Awesome. How do I find the y-coordinate of the vertex?
1.
Exactly. So I have to find f of negative 1. 4, negative 1 squared is 1, so that's 4, minus 8 minus 1. Negative 1 squared is 1, 1 times 4 is 4, 8 times negative 1 is negative 8, and I copy negative 1. Is this okay so far? Yes? Okay, so then 4 minus 9 is negative 5. So I have the coordinates of the vertex. I know it opens upward, it has a minimum, and the coordinates of the vertex are negative 1 comma negative 5. So now the next step, I'm going to ask you X intercepts. But the question is, do they exist? Because I don't want to waste my time. Do they exist?
Yes.
How do I know that they exist for sure? It opens upward. I know the range now already. What is the range? Once I found the vertex and I know it opens upward, then I know the range. What is the range?
Negative 1.
Negative 5. We're talking about the y coordinates, right? The range, not the domain. So 5, 2, awesome. So then do the x in exactly perfect. Did you hear what Alexis said? The function must cross the x-axis. If the minimum is at negative 5 and it opens upward, it cannot jump over the x-axis, right? It has to cross. Very good. How do I determine the x-intercepts?
Equates fx plus 0.
Perfect. Very good. Y equals 0 or f of x equals 0. Perfect. Either one. So I have 4x squared plus 8x minus 1 equals 0. We know 4 methods of solving, what is this, by the way? Quadratic equation. We have 4 methods. Which one of those 4 will you definitely think of? Yes, yes, I will not try to factor in. Very good, the quadratic formula, awesome. So let's do that. And remember, it's already arranged in that format. In descending order equals 0. Otherwise, I can't use this. So negative b. Good. The square root of, I forgot, I'm sorry, plus or minus, of course. Negative 8 plus or minus the square root of 64 minus 4 times 4 times negative 1. So plus 16. Very good. Over 2 times 8, which is 8. Are we okay with this so far? Yes, everyone? Okay. So then I have x equals negative 8 plus or minus. What is this? A square root of 80 divided by 8. Well, in this case, I have no choice but approximate it, because I don't know where to plot this. If you ask me, plot negative 8 plus the square root of 80 over 8, I'll say, give me a minute. I have no idea what to plot. So I'll plug in the calculator. So clear whatever. So parentheses for the top, negative 8 plus the square root of, I have to have parentheses. That's in my blood. I can't take that out. So 80. Close the parenthesis. Go outside. Close the parenthesis again. And then divide by 8. And then the other one, second and entry. And I just go and overwrite positive into minus. Good. So I got two solutions, 0.11 and negative 2.11, if you want 0.12. So now what X intercepts did we find? One, comma.
Negative 2.11. Negative. Oh, 0.
Ah.
Negative 2.11, 0.
Very good. Number 4, the Y-intercept. Now it's easy to get the Y-intercept for this function. Not Y. We're talking about the Y-intercept. Okay, so what do I get? Perfect. So when x is 0, y is negative 1. What is the ordered pair that is the Y-intercept?
0, negative 1.
0, negative 1. If you remember, 5 and 6 are words, and 7 you already gave me. What is number 7? Very good, very good. Thank you. Negative 5 to infinity. So number 5, axis of symmetry. What is the axis of symmetry? Look at the vertex. It has to be an equation. Perfect. X equals negative 1. Does it have a min or a max again? Min. And the min value, I have to put that in number 6. Min value is, of course, that's where the range starts. Very good. Is everything okay now so far? Okay, so let's graph the function. I plot the vertex first at negative 1, negative 5. I draw the axis of symmetry, which is not part of the graph. X equals negative 1. I plot the X intercepts, kind of hard. And the Y-intercept, 0, negative 1. Now, having all these, I'm going to try and graph this function as symmetric as I can and not too acute, not like this. or like this at the vertex. So careful. My graph is far from being perfect. So this is f of x, 4x squared plus 8x minus 1. Is this okay?
Yes, ma'am.
Good. Very good. Good question. Anything else for me? Have we worked on anything else? Any questions? Yes, please. Heather?
It was like a word, but kind of like the word problem of the distance, and it was like negative 0.01 x squared. I can't remember. It was like,
Oh, the one we looked at last time?
yeah.
Okay, let me finish this one, and then we'll go over what we did last time. You had a question on that problem.
Yes.
Okay, very good. What am I doing now? I'm so sorry. This one. Okay, very good. So we want to look at the following function. It's the same thing, right? We want a graph. Very good. Perfect. Good. So what do you think by simply looking at this function, what do you think I am going to do? Right away. Immediately.
Put it in order.
Yes, not in standard form. This is what they call the standard form. How?
The formula.
Just dictate and I'll write it.
A into bracket x minus h squared.
Negative at parentheses x minus.
Very good. Of course, this is my starting point. It's all twisted. I don't even want to look at that. I want to keep it in the same correct order first. Good. Now, x squared. Where am I going? In the order of operations.
And go to
This shape.
the right one.
Yes, I'm going right one. Then, I'm not there yet.
Flip.
Yes, by the order of operations, I have to flip. And then,
It's vertical.
up 4. One more time. X squared in order of operations. 1 to your right, flip, and up 4. Can anyone give us the vertex?
1, 4.
That's it. Can anyone give us number 7, which is the range? Very good. Negative infinity to 4. Awesome. By simply looking silly in front of you and moving my arms, blah, 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 you understood exactly what this function is telling us. Very good. Awesome. What is the shape? Of course, a maximum, because a is -1, which is a negative number. Good. Number 3, should I look for X intercepts? I don't want to waste my time.
No. Yeah.
Yes.
Yep.
Because look at the range. It's negative infinity to 4. It's coming from negative and it's going to positive, so it has to cross the x-axis. Good. How do I determine the x-intercepts? How do I get the x-intercepts?
0 plus
0, 4.
equate the equation to 0.
Exactly.
5, 0.
Very good. So negative x minus 1 squared plus 4 equals 0. What type of equation is this? Very good. I know 4 different methods. Which one is the most convenient in this case? You can say, yes, but you haven't cleaned it up. And I will have to say, yes, you're right. It's not cleaned up yet. what will you do?
Multiply by -1.
Subtract 4
Oh,
4.
and correct, multiply by -1. Now I should be able to identify the best method for this. And we know 4.
Square root.
Of course. Very good. So I will take the square root. I get x minus 1 equals
2. Square root. Plus or minus.
Ah, I need two solutions, right? Good. So x equals 1 plus or minus 2. I need to separate them. I have no choice. What do I do with the other? Okay, right here. I have no choice. So which are those two solutions?
3
Plus
-1.
3, -1.
Very good. 3 indeed and -1. So the two ordered pairs are
Plus 3, 0.
awesome.
-1 is 0.
Very good. Now number 4, the Y-intercept. How do I determine the Y-intercept? Yes, let's do this together. 0 minus 1, -1 squared
1,
times -1, -1 plus 4.
3.
That's it. So when x is 0, y is 3. What is the ordered pair then?
0,
0, 3.
Very good. 5 and 6 are just words. Axis of symmetry. And then the maximum, because we know it has the maximum. It has a maximum. Maximum value is, the vertex is 1, 4. So the axis of symmetry is, very good, awesome. And the maximum value is,
4.
that's it. Ready to graph this function? Yes? Okay, so let's do that. I start with the vertex 1, 4. I continue with the axis of symmetry in the hope that I will be able to keep the graph in shape. And then +3 and -1, the X intercepts, and then the Y-intercept 0, 3. This is a much nicer graph and easier than the previous one. Everything this as we expected, the range between -infinity and 4, and so on and so forth.
The range.
-infinity to 4. Very good. Is there anything else? Is there anything else? Have you worked on any of the polynomials? Are you okay with that? Is that a yes? Is that a no? Okay. Well, in that case, we are moving on. You can stop me anytime if you remember something. We can go back and look at and work on any problem you want. 3.3 is a preparation for 3.5. I'm looking for my homework sheet. Okay. So remember we completed 3.2. You didn't have any questions on 3.2. I'm hoping you will soon. We're going to finish 3.3 today and 3.5 and 3.6 after the break. I think I should not include 4.1. This was a suggested sequence by my department, bless you. I think I will not include this with chapter 3. So we will have test 2 here at the end of chapter 3, because this is totally different. These two functions are completely different than anything you've seen before. So these sections should be together. So I think that's what we're going to do. So not the first week, maybe the second week after the break.
Chapter 2 is going to be on 2.6 and 3.6.
6, 7, 8, and chapter 3. So 3.3 deals with dividing polynomials. we have two different situations here. One situation is not presented in your book, but I have to show it to you. It's the simplest of all. So we can have a polynomial divided by a monomial, meaning one term, just one term. The other possibility is, which is more complex, when I have a polynomial divided by another polynomial, not a monomial. So two or more terms. Here we have two possibilities as well. One possibility is long division. The other one, only in limited situations. The other one is not applicable always. This is applicable always. The second possibility is only when we have a polynomial divided by x minus a number. So this can be a polynomial divided by x plus 1, or a polynomial divided by x minus 5. If we have something like this, we can use this particular situation, and the method is called synthetic division. But as I mentioned, the second possibility, this is limited. That one works for anything you want, except that one. Okay? That's a totally separate situation. This can be done with synthetic division. Long division works for everything except this. Okay, I'm going to start with a simple example of a polynomial divided by a monomial. So let's take a look. Let's say 2x to the fourth minus 3x plus 10 divided by x squared. Is the polynomial from the top in descending order?
Yeah.
Good, it is. Is the denominator just one term? One product, one monomial, correct? Good. The only thing we can do here is just split the fraction. Into how many fractions? How many fractions can I split this fraction?
2.
How many terms are at the top? I can split it in 3 then. X to the fourth over x squared minus 3x over x squared plus 10 over x squared. That's what I can do. And I will have to simplify each and every fraction as much as I can. So how will you simplify the first fraction? What do you get as a simplified form of this? Very good, awesome. And then minus. For the second one, you take away an x from the top and you take an x away from the bottom. So negative 3 over x. And there is nothing you can do to the last one. And if you say to me, really, is this really division? I'll say, yes, that's the only thing I can do. Well, it may not seem like it, but that's the only thing we can do in order to simplify. It's a very important step, depending on the denominator being just one term. And this is useful for the next section. I don't know why I couldn't find an example in the book to pick for you. Okay. So now let's look at the other possibility in which we have, let's say, I'm going to pick a problem. 3x to the fourth plus x squared minus 5x plus 10. And let's suppose we want to divide by x squared plus 1. This is typical for the long division. Can I use synthetic division here? And you can say you haven't even mentioned it, or I mean, you haven't even shown the method. True. But I mentioned that if the denominator does not have degree 1 and the leading coefficient is not 1, I will not be able to use a synthetic division. Although I have to be honest, if the leading coefficient, if this is degree 1 and the leading coefficient is not 1 but 5, I could factor out 5. So there is still a way of solving, of finding the quotient and remainder using the synthetic division in this case. But not if the degree is more than 1. Oh no. The degree must be 1. But if the leading coefficient is 5 or 10 or 3, then there is a way. Good. So can I use synthetic division for this situation? No, because the denominator has degree 2. It's quadratic, correct? It's degree 2. So I cannot use. Good. So before I ask you a few questions here, I would like to present a division of two numbers. And I know you're going to say we haven't done that in 5, 10, 20 years, whatever you want to say. I will agree. We have calculators, assuming we are in the middle of the desert. And we have no juice in any electronic device. So we have to do it by hand. So let's say 2512 divided by 15. So how do I do this? First of all, why am I presenting this? Just to show you that what we're going to do with the polynomials is exactly the same thing. It will look differently because of x and because it has so many terms. And that's not the case here, but it's basically the same idea. That's why I'm presenting this to you. So first I'm asking myself, 15 goes into 25 once, right? I sort of distribute. So I'm multiplying 1 by 15. The answer is 15. But when I write underneath, I will have to change the sign because I subtract. But remember, 1 times 15 is not negative 15. It's positive 15. But I have to change the sign to the opposite sign. Then I perform the operations I see, and I have 10. I bring down the next in line. 15 goes into 101. How many times? 2 15s is 30. So it's 6. 30 plus 30 plus 30, right? So 6. So that's 90. But I subtract. 6 times I go back and distribute 6 to 15. I get positive 90, but I have to subtract, so I write negative 90. And then I have 1 and 1. I bring down the next in line. So far, so good. Okay, and now I'm asking myself, is 7 going to work? So I go back and distribute 7 times 5, 15, 5, and I carry, 35, 5, and I carry 3, so this is 10. But I have to write negative 105. However, 7 times 15 is not negative 105, correct? So then I subtract, and I get what? How do I write the answer of the division 2512 divided by 15? 167. And I have, for polynomials, I cannot omit the symbol. I have to write plus 7, which is the remainder. This is the remainder, over the divisor. In the same way, we will write the answer for the long division of these two polynomials. My question is, how do I check my answer? Look at 167 plus 7 over 15. How will I check my answer here? What if I made a mistake? All I have to do is multiply 15 by 167 and add to get what? Exactly. So this times this plus 7 should give us 2512. If it doesn't, something is wrong here. In the same way, we will check that division. Identical. Divisor times quotient plus remainder should give us this. If it doesn't, we made an error somewhere. I think now we are ready. However, there are two questions that I have to ask. Are both polynomials in descending order? Because if they're not, they have to be rearranged. They are. Second question. What is the degree of the numerator?
6.
Okay, so my students are making me cry. So when we talk about this, what type of function is this? We just solved an equation. Quadratic. What is the degree of a quadratic function? 2 plus 1? Really?
2 plus 1.
My question is the degree of a quadratic 2 plus 1 or just 2?
No, 2.
Okay. So we don't add degrees, right? We only look at the highest. Okay, good. I just wanted to make sure. One more time. What is the degree of the polynomial in the numerator? 4. I'm going to ask one more quick question. Is there any missing term here? Exactly. So degree 4 is there, degree 3 is not. Degree 2 is there, degree 1 is there, degree 0 is there. I'm going to leave a room, some space for the degree that is missing. If I don't need to use it, it's fine. But if I need it and it's not there, I will mess up the problem. Okay? So 3x to the 4th space plus x squared minus 5x plus 10, and I'm dividing by x squared plus 1. First question I ask myself. Can anyone tell us what is the first question we ask ourselves? Remember what I said here. 15 times what is 25? And I put the answer up here. So what am I asking myself now? X squared times what is? X squared times what is? 3x to the 4th. X squared, 15 times what is 25? X squared times what is 3x to the 4th? Now I'm ready for the answer. Awesome. Remember what I said? And I know you didn't like it because it doesn't make any sense. When I said we distribute 1 to 15, right? But I was preparing for this. I have to distribute 3x squared to both terms. After I'm done distributing, I have to switch the sign to the opposite sign and write below like terms. Ready? 3x squared times x squared is? I have to switch the symbol. 3x squared times 1.
3x squared or
Say it again.
you said 3x raised to power 4.
Because 3x squared times x squared is 3x to the 4th. Right? Is it okay? Good. 3x squared times 1.
3x squared.
But I have to change the symbol. And I cannot write it here. I have to write it under x squared. So negative 3x squared. Perform the operations I see. Negative 2x squared. Bring down the next in line. It turned out that I didn't need to use that space. But it has to be there. Good. X squared. What is the next question? Can anyone read the next question for us or just state it? Yes, x squared times what is? X squared times what is? Negative 2x squared. Very good. And the answer is? Here I cannot lie. Here I have to write the correct answer or the correct symbol or sign.
Negative 2x raised to 4.
Just negative 2. You have to decrease. The degree has to decrease. 2x squared. I cannot go back to x to the 4th. If I go back to the x to the 4th, 2x to the 4th times x squared will be 2x to the 6th. Everything, all degrees have to decrease. Okay? So negative 2 times x squared is negative 2x squared plus 2x squared. Negative 2 times 1. Negative 2, but I cannot write it here. It has to be changed into positive. I have to write it here. Negative 5x and positive 12. Can I continue? No. because the degree of this polynomial is 2, and the degree of this polynomial is, that's it. I have no answer. X squared times what is negative 5x? No answer. So how do I write the final answer for this? Let me copy it. I think it's better to have it on one page. So 3x to the fourth plus x squared minus 5x plus 10. Everything divided by x squared plus 1. Can anyone dictate the quotient? Very good. Awesome. Very good. Awesome. The remainder over the divisor. Perfect. Let's say I have doubts about my work. One more time. How will I check this? Multiply x squared plus 1 by, okay, let's go back here. 15 times 167 plus 7 is that. So x squared plus 1 times minus 2 plus all this should give us the top. If it does not give us the top, this is wrong. Do you need to check? Do you want to check? Is it a yes or a no? No, just, you know what I mean. I know you believe me, but do you need to see it?
No, I understand.
Is everyone okay with that then? Okay, perfect. Now let's look at the synthetic division. I'm going to use the same numerator, but I cannot use the same denominator. So of course the answer will be totally different. So let's say 3x to the fourth plus x squared minus 5x plus 10. And please choose a linear expression. Yes. Oh, Kelsey, I thought you had a question. So choose a linear expression.
2x plus 4.
The leading coefficient has to be 1. If you want 2x plus 4, I'm in agreement with it. However, I will have to do this. I am more than happy for your choice. And you will have to wait till I'm done. So it will be 1/2 multiplied by 3x to the fourth plus x squared minus 5x plus 10 divided by x plus 2. I will perform this and then I will distribute 1/2. So this is what I was saying. So if the denominator is a linear expression like this one, 2x plus 4 or x plus 2, I can use synthetic division. If it has a coefficient, I will have to pull it out. Perform this as if this one does not exist, and then whatever answer I get, it will be distributed to each and every term. It's a very good example. Good. So here's a synthetic division. So the synthetic division requires a polynomial divided by x minus a. If you compare x minus a to x plus 2, just compare these two and tell me how much is a. If you say 2, I will say no, because x minus 2 does not equal x plus 2. But if you say a equals negative 2, then I will agree. Because if you replace a by negative 2, you get this. After we establish what a is, we will put it in this little box. Then we will draw a line. You leave some room, some space between the box and this line. Next to the box, to the right, we're going to put all coefficients, even the ones that are not there. Okay? So, the first coefficient for this polynomial is 3. What is the second coefficient?
0.
Very good. What is the third coefficient? What is the next one? And the last one? Very good. Awesome. The synthetic division requires us to copy the first coefficient. Don't do anything to it. Just copy it. That's the first step. Second step, I multiply what I have in the box, -2 by 3. What do I get? I have to write it right here under 0. Perform the operations I see. How much do I get? -6. I continue. I multiply -2 by -6. How much do I get? Very good. I perform the operations I see. Very good. I continue multiplying -2 by 13. Very good, awesome. I perform the operations I see. Very good, -31. Final step, -2 times -31. I will put this in a box. What is this? And how much? Very good. What will this represent? Awesome. This will be the remainder. Now I'm coming back to the next question. We haven't finished. What is the degree of the top again? Very good. What is the degree of the bottom? 1. When I divide degree 4 by degree 1, what degree will the result, the quotient, have? Right. If I divide degree 4 by degree 1, I cannot still have 4. Right? So degree 4 divided by degree 1, the answer must be degree? Exactly. Perfect. So then you know how to write. Tell me or give me the answer. So now I'm going to copy this. I still have 1/2 in front of 3x to the 4th plus x squared minus 5x plus 10 divided by x plus 2 equals 1/2. And please tell me what to write. Awesome. Yes. That's all I needed. Yes. 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 Once we establish the degree of the quotient, then we know where to start. But we have to establish the degree of the quotient. How did we do that? We divided degree 4 by degree 1. So I have to have the result as a degree 3. Awesome. And then plus 72 over x plus 2. The final step, I distribute 1/2. 1/2 has to be distributed to each and every term, including this portion. So 1/2 times 3, 3/2 x cubed. 1/2 times -6, -3x squared, plus 1/2 times 13, 13 divided by 2x. 1/2 times -31, -31/2, plus 1/2 times 72 over x plus 2. I will simplify and write 36 over x plus 2. This is the final answer. And yes, I agree, we'll not let Jason choose anymore. That's it. I'm kidding, of course. Okay, any questions here? Yes, please.
Are we going to go over more of these?
Oh, just tell me and we will. Yeah.
Okay.
Another synthetic division?
Yeah, long division. Because those are going to be on the test, right? For the class?
Yes.
Okay. I'm having trouble processing it completely.
Okay, this was from a different class, actually. This is a review. But please tell me, what do you want me to do? Long division, synthetic division, which one?
Can we do long division?
Yes. Yes. So I'm going to choose a problem that works with both. So then we can check, and because I need to build up to 2 theorems. That's what I'm trying to do right now. Okay, here it is. 5x squared. 5x squared, that's correct. Plus 10x to the 4th minus 3x cubed plus 4 divided by 2 plus x. What do I have to do first? Yes, so let's arrange it. Let's dictate. 10x to the 4th indeed. Minus 3x cubed. Very good. and plus 4, and the denominator,
X plus X minus 10.
very good, awesome. Good. Let's start with which one? Which of the two you want to do first? Say again. Long division, very good. They are in descending order. Any missing term from the top? Yes, yes, the one with degree 1. Very good, so I have to be careful there. 10x to the 4th minus 3x cubed plus 5x squared, space, plus 4x minus 2. Can anyone phrase the first question we have to ask ourselves? X times what is 10x to the 4th?
10x to the third.
10x to the 3rd. We go back, we distribute to both terms. 10x cubed times x. I have to change the sign. 10x cubed times negative 2.
Negative 20.
X cubed. Positive 20x cubed. Perform the operations we see. 20 minus 3 is 17x cubed. Bring down the next in line. X, what is the next question? Can anyone, I want to hear one time, someone saying what is the next question?
Yeah.
Yes, Harry?
Positive 17x squared.
So the question is x
X
times what is 17x cubed?
It should be 17x squared.
Yes, awesome, but I also need the sign. If I put 17, yes, indeed. Remember, we do not lie at the top. 17x squared times x.
17x cubed.
Yes, now I have to change the sign. 17x squared times negative 2. Negative 34x squared, but what do I have to write?
Plus 34. X squared.
34 plus 5 is 39, x squared. Can anyone now? Yes, you can, but it's still far away, but you can. Can anyone tell us the next question? Say it again. X times what is 39x squared? I need sign. Yes? Very good. Is that clear? This is degree 3, degree 2, degree 1. It has to decrease. If you go back to something higher, something is wrong. So 39 times x, 39x times x is?
39x squared.
I have to subtract. 39x times negative 2. 78. Negative 78x. What do I write? Positive right here. Right here. Positive 78x. And now I bring down 78x plus 4. Can anyone tell us now the next question that you were ask yourselves? Yes, x times what is? Yes, so what do I write at the top? I cannot lie at the top. So 78 times x is negative 7. It's positive 78, negative 78x. 78 times negative 2, that's 166, I believe. It's negative. What do I write? Plus 166. These two go away. What do I put in the box? 170. 78 times 2. So can anyone give us the final answer? So I can.
This is the part that confuses me.
Which one?
Just like rewriting it, the answer.
Oh. 2512 divided by 15 is the quotient, 167, plus the remainder over the divisor.
Oh, okay.
Better?
Yeah.
Good. So can anyone dictate?
10x to the third cubed plus 17x squared plus 39x plus 78 plus 170 divided by x.
Is that clear? Better? Perfect. Awesome. Good. Now we want to do the same thing with the synthetic division. What goes in the box? 2. Awesome. Can anyone dictate the coefficients that go next to the box to the right? 10.
It's always a constant.
No, we want to do both. We want to do both. Yes.
I'm sorry, where'd you get the 2 from? Did you just take it from the x minus 2 and make it
Yes.
positive? Okay.
I didn't make it positive. So I'm not making it positive. Look, I'm comparing x minus 2 to x minus a. X minus minus, so this must be 2. Good. In descending, the first coefficient is 10. Next one. Next one. Next one. 0, 0. There is nothing here, right? 0. And then 4. Perfect. First step. What do I need to do? Yes, bring down the 10 or copy 10. Perfect. Next step. 2 times 10. 20 minus 3. 2 times 17. 34 plus 5. 2 times 39. 78 plus 0. 2 times 78. And in the box. Now let's compare. That's why I wanted to use the same. All the numbers are identical. So first I copied the 10, then I had the 17, then I had the 34, and then the 39, and then I had the 78, and then I had the 166, and then I had 170. Everything that you see here is basically here. Now when I use synthetic division, I have to go back and ask myself, what was the degree of the numerator? 4. What is the degree of the divisor? So when I divide degree 4 by degree 1, what degree do I get? Because otherwise I will not know where to start here. 3. So what would be the answer then? 10x cubed plus 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 plus. Is that better now? Perfect. Anytime. So now, here's a question for you. 9 divided by 3. Can I say that this is 3 plus 0 over 3? Is that correct? This is 0. Is 9 divided by 3, 3? Very good. So when the remainder is 0, what can I say about 3? What is 3 for 9? Remainder 0. 3 is what for 9? I'm missing a very important word. Remainder 0 means that 3 is a, yes, is a factor for 9, or of 9, if you want. Good. So now, if I say to you that when I divide this polynomial by x minus 2, and let's say I say remainder 0, what will you say about x minus 2? What is x minus 2 for p of x? Then x minus 2 is a, exactly, a factor, thank you, of p of x. What if the remainder is 5? If when I divide these two, I get remainder 170. Can I say that this polynomial is a factor of this one?
Mhm.
I cannot, because the remainder is not 0.
Not 0.
Is that clear? Good. So this is what it's called, the factor theorem. Factor theorem. But it works only in the cases in which the synthetic division works. So when we divide p of x by x minus a, and the remainder is 0, then, say it again, x minus a must be or is what? A factor of p of x.